Are you a finance professional or aspiring finance professional with zero to little coding experience? Well, this video is a great starting point for you because we're going to start at the very basics of how to use Python and work our way up to a bit of a more intermediate example of how to pull in stock prices and plot the returns of those stock prices in Python. Before you can actually start working with Python, you actually need it downloaded on your computer. So you can either Google download Python and click the first link, or follow the link in the description to this page here if you do not already have Python, and hit this box, download Python, and depending on your browser, you might see this pop up, or you might need to go to downloads in your computer and just open up that download for the Python installer and just follow the install instructions. I would just use the standard one here. I'm not going to click this because I already have Python installed. But yep, follow along with that box. And then once you have Python, you're going to need to get the development environment to run Python. So you can either type into Google download Anaconda, or you can follow the link in the description to get to Anaconda, and you'll show up on this page. And what you're going to want to do is just hit download if you have Windows. I think it should detect whether you have Apple or Windows or whatever, and hit download, and then follow again the installation instructions on whatever file downloads there. And then once you have Anaconda up and running and you open Anaconda, you'll see this, the Anaconda Navigator. And this has all sorts of popular development environments for Python. I think Jupyter Notebook is probably the most popular one, but I have some problems with that one on my own computer that I record videos with. So I actually prefer VS Code over Jupyter Notebook. So if you want to follow along with the exact environment I'm using in this video, click launch on VS Code. But if you want to use the most popular one, you can also click launch on Jupyter Notebooks, and it will function the same way for all intents and purposes. So I'm going to launch VS Code. So VS Code will open like this. And there's going to be a number of different options. I'm just going to start by hitting new file here. And then it's going to ask us what type of file we want. So go in and type Jupyter and find Jupyter Notebook. So I'm going to click that to open a new untitled notebook. And I'm going to show you the most simple code that you can run, which is just to print hello world into the console. And so we're just going to start with what's known as a function in programming. And this function is one called print. And we'll put in quotes, hello world. And then we'll just run that. And you'll see that when we click run, it's asking us to select a kernel for this document that we're in. So I'm just going to click on the Python version that popped up there. And now it is going to run for me. And it prints out hello world into the console in half a second. And if you followed that, congratulations. You may have just printed your first line of code in programming. Now, don't freak out. You're going to see a lot of additional text on the screen right now, but it doesn't affect any of the code. I've just added it to make it an easier learning process so you can see in words what we're doing at each step. Don't worry about it. If you follow along with just that blank file that we created before, like this one, and just use the same code as I'm using, it'll all function the same way. So don't worry about it. So we just printed hello world. But one thing I want to see is what type of variable did we just print? And so we can do that by doing essentially the same thing, like this print hello world. But now inside of the print, we're going to do type. So we're asking what type of variable it is, and we're going to put brackets around hello world. So first we're finding the type of variable that hello world is, and then we're printing that variable. So we run that. And so first it executed this line of code, which was to print hello world right there. And then second, it printed the type of variable it was, which we found out its class is a string. And so a string variable is just a variable that is text. And there's all sorts of different variables in Python and other programming languages. Some other variables might be integers, which would be like 1, 2, 3, 4, etc. Or dates, like March 13th. Or even floats, which are numbers with decimals after them. So we'll get into more of these as we move along. So one thing I want to do is show you another way that we could print out this hello world variable, which is to first put it into a string variable. So let's just call this my first string. So here we're saying my first string is a variable that will be a string and it's equal to hello world. And then now we can do print, and then we'll print out that variable my first string, and I will hit run. And there we go. So we accomplished the same thing just by declaring a permanent variable. Here, this wouldn't stick around for code later on because we're just printing it off. But if we wanted to use this string later on, now we have it stored in a variable there. Just to clarify one thing before we move along is that these boxes that we've been writing the code in are actually called cells. And so in order to have made this second cell, I would have needed to add another code cell. And so if I go back to the more simple file and you're working from a screen that looks like this, how you can do this is you would just go and put your mouse underneath the first box somewhere in the center of the screen, and you'll see this option plus code pops up. So I'll just click that, another code box pops up, and then I'll put the code in and run it, and you can see now we've just run a separate cell entirely. Now that we've got our head around what are strings, let's move on to integers, another variable type. And what we're going to do is just declare two different integers, and we'll multiply the two of them together. And so let's assume that we've got a holding of some sort of stock, and we want to find out the number of shares that we have and the price of those shares and multiply them together to find out what is our total value that we have in those shares. How would we do that? Well, let's start by declaring our first integer. So here we've declared a integer variable called stock price, and we're setting it equal to 15. So you can think of this as $15. Now let's declare one that tells us how many shares we have. So here we're saying that we have 10 shares. Now we want to multiply the two of them together and print off the total amount of money we have in this position. So what we've done here is we've made a concatenated string. So we're going to print the amount of money I have in these stocks is, and then the plus sign tells this print statement that there's another component that we want to concatenate to this first string, which is a second string. And so we're using a function that turns an integer into a string. So we're going to multiply stock price times number of shares, and we're going to convert it to a string, and then we're going to concatenate it all into one large print statement. Now let's run that. And it tells us the amount of money I have in these stocks is $150. If you end up programming often, you're going to be writing a lot of loops, and in particular, for loops. And so what a for loop is it is a control flow statement that allows us to iterate over a sequence of values, such as a list or a string, etc. And we execute a block of code, something that we want to do with each element in that sequence. So let's start off by declaring a list. And so let's just name the list values. And I'm going to fill values with the numbers 1 through 10. And I do that by putting in these square brackets, and then I just type 1, 2, 3, etc. So now we have declared this values variable, which should be a list, but let's print that off just to make sure that it is a list. So we will print the type that values is, and we find out, yes, it is a list. And now we want to iterate through this list with a for loop statement. So we'll start off by typing for I in values. And what this is telling us is that I will just be used as essentially a counter. So first I is going to be this part of the list, and it will do something to that part of the list, and then it will go to the next one, and I will become this index, and then I will become this index next, and so on and so forth. So for this simple example, all we want to do is just print the values. So we'll print I. So for every element in this list, let's print that element, and let's run it. And so we see first it went to this part of the list, and it printed the value there, which was 1. And then it went to 2, and it printed 2, etc. Simple enough? Now, I know a lot of you guys watch my Excel videos, so this one might be a little bit more intuitive for you at first. So we're going to execute an if statement. And an if statement just allows us to check if some sort of condition is true or false, and then do something with that code based on whether the value was true or false. And let's just get right into an example to not overcomplicate things. So let's declare a new variable, and we'll just call it A, and we'll set that equal to 15. And then let's make another one called B, and we'll set that equal to 10. And so let's write our first if statement. So we'll say if A is greater than B, we want to do something. Well, what do we want to do? I just want to print A is greater than B. But what if B is greater than A? Then I want to print that B is greater than A. So let's just write this code out in a simple format. So we've tackled the first part of our problem. If A is greater than B, we'll print A is greater than B. But now what do we do if B is actually greater than A? We can type in else if, which is shortened by elif, so ELIF. And then we're going to do B is greater than A. And then in this case, we'll print B is greater than A. And now let's run this code. And so there we go. Because B or A is 15 and B is 10, we found that A is greater than B. But what if A was suddenly changed to, let's say, 8? Let's run that. And now we find that B is greater than A. Perfect. And now let's do another for loop with an actual if statement inside of that for loop. So let's type for I in values. And remember that values is just this list of the values of 1 through 10. Now we're going to want to say if I is greater than 5, we want to print that value. So basically what we want to have happen is for it to not print any of the values that are in this range here, 1 through 5, but we do want to print these values 6 through 10. So let's see if our code works there. And there we go. So we iterated through the entire list of values of 1 through 10, and for each one we checked a certain condition, and then if that condition was met, we printed the value. Up until this point in the video, we have only used the functions provided to us in the core Python software. This is known as vanilla Python or pure Python. But now we're going to get a little bit more complicated and import external libraries that we need to do some more complicated things in Python. So bear with me as we install these external packages and start to use them. So we will start by importing 5 separate packages. And so you likely don't have any of these on your computer right now as it stands. So what we're going to do is we're going to go to the command prompt. And for each one of these that you don't have, you're just going to type in this name here of that package, and you're going to do pip install. And for the first one, for example, we'll do yFinance. And you would hit enter and it would install that package. I don't necessarily need to do this because I already have the package installed. But there we go. So then you'll just go for all 5 of these. So you'll do pip install pandas, pip install data, pip install datetime, and pip install numpy. And then we'll get into what these do in a little bit here. Let's run the import of all of these, and if this runs successfully, you know you did this part correctly where you pip installed everything properly. If not, it might tell you that one of these is not installed in your computer. Then you'll just do pip install that one. And then we'll move on. And so what we're going to do in our example today is basically we're going to set a date range of a period of time that we're interested in. And then we're going to set a list of stocks that we're interested in, and we'll pull all of the stock prices for all of those stocks for that period of time. And so the first thing we're going to do is set up this date range. And, I'm a man of the present moment, so I want to set up my date range based on today. And so let's start off by declaring a variable called endDate. And let's use this datetime package that we imported here, and let's find out today's date. So we'll do dt.datetime. So this is a function within datetime package called now. And this should give us today's date. And if you want, I can just print this out really quick just to make sure that we imported that correctly. So here we go. Let's run that. And like I said, so we're printing off today's date, which for me right now is 4/16/2023. Now let's find our start date. So what would be the first date in this period of time? And that's just going to be based on end date. And then we're going to have to subtract, and we can use another function within this date time package, right? Which is called time delta. So we'll do dt time delta, and we're going to have to set it equal to a certain number of days. And so what I'm thinking would be interesting would be setting days equal to, let's do 365, right? So that's the number of years, and then we can just set up a certain number of years. So let's just set this to 5. So we're going back 5 years times the number of days in the year, and that will be our start date. And then another way that we can print both of these off just to make sure we've got everything right is just put end date, comma, and then type start date. And then let's run that. And so we see that we've got a start date of 2018, which is on April 17th. And it even goes down to the hours, minutes, and seconds, but that's just not necessary for us. Now we're going to create a list of stocks that we're interested in. And I wish this was like a live stream so I could ask you guys what you want to see, but you know, it's fine. I'll just go with some things that I'm interested in seeing. So let's do stocks. And first off, let's just say we want to see Microsoft. Maybe we're interested in Microsoft. So this is where you would actually go up and you could look on, let's say, Google or Yahoo Finance or anything and look up the actual tickers of the stocks you're interested in. Another one I might be interested in is SPY. So that's the biggest S&P 500 index ETF. And let's say another one I'm interested in is the largest NASDAQ ETF, QQQ. So let's run that. And basically, we've just created a list of 3 stocks that we want to see the prices of. Now that we have the list of the 3 securities that we're interested in, we're going to have to download the data for these securities from Yahoo Finance, which is really simple and free. It's just 1 line of code. So we'll start off by creating a new data frame, and we'll just call that df. Now, one thing to keep in mind is that in Python, a data frame is basically like a table. So if you think of a sheet of data in Excel that has a table in it, think of a data frame as that table, but in Python. So we've wrote our line of code, and one thing you're going to have to keep in mind is, so this YF is how we imported the Yahoo Finance library. And so we're calling on Yahoo Finance API to download this list of stocks here for the start date and the end date that we declared earlier above in our code. Now let's just run that. And now you can see this is taking a bit longer than all the other code we've written because it's actually having to go scrape Yahoo Finance's website and download that stock data. Now let's just take a look at what we downloaded. So we can take the data frame, so the df here, and if we do this function called head, it'll just print the first 5 rows of the data frame. So let's take a look. And so what we've got now is a table of data, or a data frame, that has the adjusted close here for all 3 of these stocks. It also has the normal close price for each of these stocks. So all of these columns, the first 4 columns, are all related essentially to prices, or I should say the first 12 columns, because there's 3 columns within each subset. And then finally we have the volume. But actually, for this exercise, all we're interested in is this specific part right over here, the adjusted closes, because it's the best for measuring stock performance, because adjusted close accounts for dividends and stock splits. So let's get a separate data frame that only has the adjusted close values in it. So let's just call that adjusted close prices, and let's set it equal to, so we're going to call this data frame here df, and then all we're going to do is just put the square brackets and grab the adjusted close columns right? Because we're using this text here, adjusted close, and let's run that. And there we go. So now we've broken out these prices into their own table. And once again, we can print this if we want to see what it looks like. If we just go with .head, and now we can see we've just got this one specific part of the table here. Now that we've got our adjusted close prices, we need to calculate the daily returns. And the way that I'm going to recommend doing this is calculating the natural logarithm of the daily changes in the returns. And the reason we do this is because when we try to annualize those returns, it becomes additive. So let's do that by finding those daily log returns and store them in a variable called log returns. And to do this, we do np.log. And so this is where we're just taking the logarithm. And so np is what we imported from the NumPy library. So right here, we said import NumPy as np. So this is a library that has a lot of different math functions that we can use. And so this is going to be very useful in a lot of financial applications, that NumPy library. And now we're just going to take the adjusted close prices, and we're going to divide by adjusted close prices dot shift 1. And so the way that you can think about this is, let's say we're looking at this date right here, 2018, so April 18th of 2018. So for the daily return for Microsoft on that day, it will be this value and then shift up 1, so divided by this value, and we're just taking the logarithmic change of that right there. And don't overcomplicate it. It's really not as difficult or complicated as it seems. So now let's once again just take a look, and we'll run that. And there we go, right? So we're dividing each row by the row above it. The first row will be divided by nothing, so those should be NA values. But the rest, this gives us our daily return for each of these days on each of these securities. Now that we have our daily returns, let's calculate the cumulative returns. And like I said, because we use the logarithm function, this is going to make our life really easy on this step because they are additive. So let's create a new variable called cumulative log returns. And let's set that variable equal to the log returns dot sum. And so what this is going to do is basically at each date, it's going to take the previous value, add it to the next day's value, and then store that as the value. And then it'll go to the next date and add this value to that. And then it'll go to the next date and add this value to that. So it's just going to keep increasing or decreasing over time, depending on if the stock's going up or down. So now let's run that. And now finally, let's plot the cumulative returns that we've calculated, which will give us an indication of just how our investments would have performed had we invested in any of these three securities starting 5 years ago. And this is very easy as well. So we'll just take this data frame that we have here, but now we'll call the plot function on it. So dot plot, and we need to give it a title. So we'll say the title equals cumulative returns. And then we need to do a comma because we need to set another parameter, which is fig size equals, and we'll just set it equal to 10 and 6 for now. And let's run that code and see our beautiful looking graph. So look at that. We can see, had we started in 2018 back here, we would have gained approximately, let's say about 60% or 55% in the S&P 500 index. But then we see the NASDAQ index QQQ actually outperformed that at about 70%. And then had we invested in Microsoft, we would have made almost or more than double what we'd made in the S&P 500 index. So this is just one fun, quick example of how you can use Python for finance, and there are many, many more to come. So subscribe to this channel for more content just like this, where I'll go into even more complicated tutorials and ones with better real-world applications than the one that you just watched. Thank you for watching.